Let's now talk about the three main methods of assigning probabilities. The first method that we're going to talk about is the classical method. Okay. Now we use the classical method when outcomes are equally likely or can be assumed to be equally likely. And when outcomes are equally likely, the probability of any given outcome is equal to 1 over n, where n is just the number of possible outcomes of an experiment. Now let's look at a couple of examples. Let's consider the coin flipping experiment. Now you probably have heard that when you flip a coin, the probability of getting a head is 1/2, and the probability of getting a tail is 1/2, or 50%, right? Let's see where those numbers come from. So when you flip a coin, there are two possible outcomes, right? And the two possible outcomes are head and tail. So now if the coin that we flip is a fair coin, then head and tail are equally likely to appear. And so the probability of getting a head, which is equal to the probability of getting a tail, is going to be equal to 1/2. And this is because there are two possible outcomes of this experiment. Let's consider another example. Let's look at the die rolling example. So when you roll a die, there are 6 possible outcomes. And the outcomes are 1, 2, 3, 4, 5, and 6. Now again, if the die is a fair die, then the outcomes are going to be equally likely, and so we have the probability of getting a 1 equals a probability of getting a 2 equals a probability of getting a 3 equals a probability of getting a 4, 5, and 6, which is going to be equal to 1/6, and this is because there are 6 possible outcomes. Now, this method of assigning probability gives us a very important formula, which is that the probability of an event is going to be equal to the number of ways the event occurs divided by the total number of possible outcomes. Okay. Now to understand this formula, let's look at a quick example. Suppose that we go back to the die rolling experiment. So if we go back to the die rolling experiment, and let me define my event of interest as getting an even number. Okay. So if I define my event of interest as getting an even number, then how many ways can that happen? There are 3 ways that can happen, right? I either get a 2, a 4, or a 6. Okay. Now recall from the previous video, we said that the probability of an event is the sum of the probabilities of the sample points associated with that event. That means that the probability of getting an even number is going to be equal to the probability of getting a 2 plus the probability of getting a 4 plus the probability of getting a 6. And because we know each of these is 1 over 6, then the probability of getting an even number is going to be 3 over 6. Okay? But then notice that 3 is just the number of ways we can get an even number. Okay. And 6 is just the total number of outcomes. And so instead of adding the probabilities of the individual sample points, all you have to do is just to take the number of ways the event occurs and divide it by the total number of possible outcomes. Now the second method of assigning probabilities that we're going to look at is the relative frequency method. Okay. So we use the relative frequency method when the experiment is repeated several times and data are available. Okay, so use when the experiment is repeated several times and data are available. Let's look at an example quickly. Okay. Now last year, the record of the West Georgia football team was 10-2, right? So record of a football team is 10-2, so 10 wins and 2 losses. Right, so according to this, the probability of getting a win is just gonna be it's gonna be equal to 10, which is the number of wins in the that you observe, divided by 12, which is the total number of repetitions of the experiment. Okay? And then the probability of getting a loss is equal to 2/12. Now there's an inherent weakness to this method. And the weakness is that this method may not give us the true probability of an event. Okay, what do I mean by this? Let's consider an example. Suppose that let's go back to the coin flipping example. Now, we have shown that we know that the probability of getting a head is equal to the probability of getting a tail, which is equal to 1/2, right? If we have a fair coin, right? Now, suppose you take out a coin right now and flip it 10 times, right? Suppose we flip a coin, say 10 times, right? Chances are, the probability of getting a head from that 10 repetitions of the experiment is not going to be 1/2, and the probability of the tail is not going to be 1/2. Right? It's just the nature of flipping a coin, right? So the idea is, if the number of repetition so if the number of repetition is relatively low, using this method, the relative frequency method will yield wrong probabilities. As the number of repetition increases, so in fact, as the number of repetitions it's terrible. Repetitions increases, right? The probability of getting ahead will approach 0.5, and the probability of getting a tail will approach 0.5. Okay? So the idea is to get a reliable probability using the relative frequency method, you're going to have to repeat the experiment a lot of times, and that is potentially costly, right? So that's the weakness of this method. Now let's go ahead and look at the last method of assigning probabilities, which is the subtractive method. So we use this method when data are not available. So we use this method when data are not available and we can't assume equally likely outcomes. In that scenario, probabilities are assigned based on beliefs, feelings, etc. And so the obvious weakness of this method is that it's not scientific, right? And will very likely be biased. So the main method of assigning probability that we will care about in the course is the first one, which is the classical method. Okay. So in this video, we talked about the three methods of assigning probabilities: the classical method, the relative frequency method, and the subtractive method. And we discussed the weaknesses of the latter two, and so the focus of this course is going to be on the first one.